Oftentimes in mathematics we deal with something called a summation, where they're asking us to find a sum of several terms that have been found by going through a particular formula. In this first example we have the summation k equal 1 to 4 of k squared. Our index of summation is the letter K in this example, and you reference what the letter is used in the bottom of the summation symbols to see what your letter of summation is. And you have an expression that is involving that letter of summation possibly, or some other variables as well. Now what you are to do with this is start with plugging in the first number that's listed at the bottom of the summation in for your letter of summation. Do the process that the term is asking you to do, and then you go plus for sum, and then go to the next integer above that, and you work your way through until you hit the top number, and that's when you stop. And then you find the sum for that answer. So here we have the summation k equals 1 to 4 of k squared. So we're going to start by putting 1 in for k. So we have 1 squared, and then plus for the summation. Now we're going to put 2 in for k, the next integer, so 2 squared, and then again plus for the summation. 3 in for k, so 3 squared, and then plus for the summation. And then finally 4 in for k, so I'll have 4 squared, and then I stop there because that's this top number. Remember, the top number tells you where to stop. So now we're going to go through and do our order of operations. 1 squared is 1, plus 2 squared is 4, plus 3 squared is 9, plus 4 squared is 16. And then we go ahead and find our total. 1 plus 4 is 5, plus 9 is 14, and 14 plus 16 gives me 30. So 30 is the result of the sum k equals 1 to 4 of k squared. Okay, next we have another problem where we have our summation k equal 1 to 5 of k. So again, we have our letter of summation is our index of summation is our k, and this is just the k to the first. And I'm going to do the sum, the addition, starting with plugging in my bottom number here, 1, and incrementing up integers until I hit the top number of 5, and attaching everything with a plus. So we'll put 1 in for k, and then plus, we'll put 2 in for k, and then plus 3 in for k, and then plus 4 in for k, and then plus 5 in for k, and this time 5 is our top out number, so we stop there. Okay, we're going to go ahead and find out what the total is. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, and plus 5 gives me 15. Okay, so now let's go to the next one. Here I have my index of summation is k, but I just have a number that I have in my argument here, and then I'm going from k equal 1 to 5. Well, I'm still going to do the summation, and I'm still going to think about the increments starting from 1 and doing the integer values until I get to 5, but each time my term is just going to be the constant 7. So when k is 1, my constant 7 is my term, plus when k is 2, I have 7, plus when k is 3, I have 7, when k is 4, I have 7, and when k is 5, I have 7. And then I stop, because that's the top number. So here I just have 7 plus 7 is 14, plus 7 is 21, plus 7 is 28, plus 7 is 35. So we have that summation is 35. So in these examples, you had the expression that you're supposed to run your numbers through from the index of summation, and then you attach them each with a plus because it's a sum, and then you stop when you get to the top number, and you actually do the mechanics of the order of operations and get your total. In the next segment, we're going to look at some of the types of summation questions that can be found that total without actually having to go through all of the individual manipulations.